All right, let's start off on number 1 here. So this one, I'm trying to solve for t. So I would just FOIL out. I would just write this as t minus 7 times t minus 7. We'll FOIL that out as t squared minus 14t plus 49 equals, and then over here I got t plus 7 and t plus 7. I wouldn't think about a u substitution here since we have different things in those parentheses. So here we go, we'll go t squared plus 14t plus 49 plus 28. All right, so then we're going to get everything on one side. You could combine like terms over on the right side, but I actually see here I can subtract 49 and actually just get rid of those. So that's going to make it just a little bit easier on me. I'm going to subtract the t squareds, and those also cancel out. I'm going to add the 14t, which will not cancel out. Oh, you know what? I probably should have moved that over. All right, it's okay. So 0 equals 28t plus 28. I would then subtract the 28 over, so negative 28 equals 28t, and then divide by 28. So t equals negative 1. All right, next up here, number 2. So for this one, we wanted to isolate m. So I would first multiply the r squared over to the other side. And so we get f times r squared equals g times little m times big M. And so then we would just want to divide by big G and big M since we're trying to isolate little m there. So there you go. All right, next up, number 4. So for this one, what would we want to do? Trying to isolate R1. And so I would first subtract 1 over R2, I guess, to the other side. So I have 1 over R minus 1 over R2 equals 1 over R1. Now, I have not yet isolated R1 because it's in the denominator here. So what I'm going to need to do here, I can't flip it when it's one fraction equal to 2 fractions. So I'm going to go ahead and get a common denominator here. And remember, kind of these subscripts are just, you got to think of them as different variables. So R is different than R1, and that's different than R2. So this is going to be R2 minus R over R times R2 equals 1 over R1. And then what we can do is actually, I'll go ahead and cross multiply here. So R1 times R2 minus R equals 1 times R2, which I'm just going to call R times R2. And then I can just, I'm not going to distribute because I'm just going to divide this over. And then I'll be done. All right, next up here, number 5. So for this one, I'm trying to isolate x. I would kind of first multiply both sides by the denominator here. It's always going to make it easier when you have a denominator. All right, and so on the left side here, it's going to cancel out. I'm going to get ax plus b equals, I'm going to go ahead and distribute that 7 in there. So I'll go 7cx plus 7d. Now, we have x's now, which we're trying to isolate. We have them on each side. I don't really want that, so we're going to move everything with an x to one side. I'll go ahead and move this to the left. And we're going to move everything without an x to the right side, so I'm going to move this over here. And so we'll cancel that and cancel that. So we get ax minus 7cx, which are not like terms. We'll keep them separate. And then over here we have 7d minus b. And so then I'm just going to, now on the left side that I have all my x's on the same side, I'm going to GCF the x. So it'll look like that. And then we'll just divide both sides by that parentheses. And that's it. All right, next up here, let's see, I would go ahead, we're trying to solve for x again. I would go ahead and distribute that in there. So we got a squared x plus a minus 9 equals xa plus 9x. So I would get everything with an x on one side again. So I'm going to move, let's move this over here, that over there. And then we're going to move all this stuff without an x over to the other side, so minus a plus 9. So then we get a squared x minus xa minus 9x equals negative a plus 9. And so now you're going to factor out that x and just divide the leftovers to the other side. I'll let you guys try it out. All right, next up here, we're trying to isolate for r. So I would actually multiply by 3 to get rid of that 1/3. So that's going to be 3v equals pi r squared h. Then I would divide by pi h. And so then I would square root both sides to get rid of the squared. Now in this case, since we created that square root, we're going to need a plus or minus here. And so I'm just going to, since it says enter the answers as a comma separated list, I'm going to write that once like this and then once as negative. I think you do have to put both. All right, next up here, again, we're going to solve now. Now I'm going to go ahead and distribute that. So I get 6x squared minus 6x equals 6 minus 11x. I see that this is a quadratic, so I want to get one side to 0. 6x squared plus 11, oh wait, no, that's plus 5x minus 6 equals 0. All right, now all right, so we have that a value of 6 here, so we're going to have to multiply a times c, which would be negative 36 and positive 5, so that's 9 and 4. All right, and then since we have that a value, we're going to have to split up this middle term with those numbers, so we get 9x and negative 4x. And then we'll group these together. So the first group I can take out 3x, which leaves me with 2x plus 3. The second group I can take out negative 2, which leaves me with 2x plus 3, which means we got 3x minus 2 and 2x plus 3 equals 0. Now I need to set each of these equal to 0 and solve individually. So 3x equals 2, x equals 2 over 3. And then 2x equals negative 3, and x equals negative 3 over 2. Since the original equation was not a radical or a denominator, I don't have to worry about extraneous solutions. All right, next up here, we'll work on number 10. So now we're going to do some fractional equations here. So I always like to kind of do these, get a common denominator first. So I'm going to multiply this one by x squared. I'm going to multiply this one by x minus 8. Now I'm going to have that common denominator of x squared times x minus 8. And so I got over here, I got 8x squared. And over here I have to distribute the negative 16, so minus 16x. And then plus, let's see, it's going to be 128. Okay, and then that's going to equal 0 over 1. And so then I'm going to go ahead and cross multiply here. So then obviously 0 times anything is 0, and then 1 times anything is just itself. So really I'm just solving this now, so that's pretty easy. I do see we have a GCF here, and it's 8, so I'm going to take out an 8. That leaves me with x squared minus 2x plus 16. All right, and I can try to factor that, multiplying to 16 and adding to negative 2, so 4 and 4 doesn't work, 8 and 2 does not work, so I guess I'll have to use quadratic formula here. So we'll say x equals negative b plus or minus the square root of b squared minus 4ac, and then all over 2 times a. Now inside the radical here, that's looking like it's going to be negative. Let's see, 4 times 6 is 4 minus 64. So that is 2 plus or minus the square root of negative 60 over 2. Now it says if there's no real solution, enter no real solution. And so this one will have an imaginary solution, but it's asking for a real solution. So I'm going to say no real solution. All right, next up here, we're going to create our common denominator again. So I'm going to multiply this one by x plus 2, that one by x minus 4. So we got x minus 4 times x plus 2 on bottom. On top, we're going to have x plus 2. Technically, we're distributing the 1 in there, plus x minus 4. And that is 2x minus 2 over x minus 4, x plus 2 equals 8 over 7. So now we'll go ahead and cross multiply here. I don't see anything we can cancel out. So it's going to turn into 8 times x minus 4, x plus 2. equals 7 times 2x minus 2. I would go ahead over here and FOIL. So I'll go ahead and FOIL those. So I get x squared minus 4x plus 2x is minus 2x minus 8. And then we'll distribute that in there. So we get 8x squared minus 16x minus 64 equals, and now I'll go ahead and distribute that. So that's going to be 14x minus 14. So now I want to get one side to 0, so I'm going to subtract the 14x over here, and I'm going to add the 14. And so that's going to give me 8x squared minus 30x minus 50 equals 0. I'll go ahead and GCF a 2 here, which gives me 4x squared minus 15x minus 25. And now I'll go ahead and do a diamond here. So remember we have the a value here, so we're going to have to multiply those together. So it's a times c is negative 100, and that's negative 15. So that sounds like a 20 and a 5 with a negative 20. So I have to split that up. So I get 4x squared plus 5x minus 20x minus 25. The first group, we can take out a x, which leaves me with 4x plus 5. The second group, we can take out a negative 5, which leaves me with 4x plus 5. And so I get x minus 5 times 4x plus 5 equals 0. So this one would be x equals 5, and then this one, if you set it equal to 0, would be negative 5 over 4. Now I need to check that neither one of those make one of the original denominators 0, and they don't. 4 and negative 2 would have been extraneous, but these ones are good. All right, next up here, we have, let's see, radicals on both sides, so I can just square both sides right away to get rid of those. So 7 plus x equals x squared plus 1. I want to get one side to 0 here, so I'm going to say x squared minus x minus 6. And that'll be x minus 3 and x plus 2. So x could equal 3 or negative 2. Now, let's see. We've got to make sure here that since this is a radical equation to start with, that we plug these in. So radical 7 plus 3 equals the square root of 3 squared plus 1. So radical 10 equals radical 10, and that checks out. Over here, we get the square root of 7 plus negative 2, so square root of 5, equals the square root of negative 2 squared plus 1, and so that'll be rad 5, and so that one also checks out. So these are actually both correct. All right, next up here, 13 and 14 are similar. I'm just going to do number 14. So we need to isolate the radical first. So in this case, I'm going to subtract the 2 over. So the square root of 7 minus x equals x minus 5. Now we need to square both sides. So on the left side, that just gets rid of the radical, but on the right side, we need to write it twice and FOIL it. And so that becomes x squared minus 10x plus 25. So then we get one side to 0. And we get minus 9x, and then, let's see, 25 minus 7 sounds like 18. All right, so we'll factor that, 18 and negative 9. So that turns into negative 3, negative 6. So x minus 6 and x minus 3 equals 0, which means x can equal 6 or x could equal 3. But I need to check these by plugging them into the original equation. So I'm going to try 6 first. So 7 minus 6 in a radical plus 2 equals 6 minus 3. So the square root of 1 plus 2 equals 3. So 1 plus 2 equals 3. That sounds great. So 6 sounds good. Now the other one here, the square root of 7 minus 3 plus 2 equals 3 minus 3. So the square root of 4 plus 2 equals 0. And it says 2 plus 2 equals 0, which is not true, which means that this one is an extraneous solution. So you should only be listing 6. All right, next up here, we're going to solve this one. It looks like we can factor this one because this power is half of the first power. So think of two numbers and multiply to 14 and add to negative 9. That would be negative 7 and negative 2. So I can write this as x squared minus 7, x squared minus 2. And now I can set these equal to 0 individually. So x squared equals 7, which would mean x equals plus or minus rad 7. And then x squared equals 2, which means that x equals plus or minus rad 2. So we got to list all these out. So I would write this as negative rad 7, comma rad 7, comma negative rad 2, comma rad 2. All right, next up here, this to me looks like a u substitution, so I'm going to let u equal x plus 8. So I'm going to say 8u to the 1/2 minus 9u to the 3/2 plus u to the 5/2 equals 0. So I'm going to GCF here u to the smallest power, which is 1/2. Now that's going to make this go away, and this should be dropping all my exponents, which this one will drop down to just the first power, and then this one will drop down to the 4/2 power, which is actually squared. I would just rearrange that into kind of the normal form, because I think we could do a diamond factoring on that. So I think if two numbers multiply to 8 and add to -9, it's -8, -1. So I got u minus 8, u minus 1, with this u to the 1/2 out front. And so now we'll plug u back in, and so this one will be x plus 8 to the 1/2, and this one will be x plus 8 minus 8, and this one will be x plus 8 minus 1. And so this one's actually just x, this one's x plus 7, and this one's x plus 8 to the 1/2. So I'm just going to set those equal to 0 individually, so I know that I have an x there, so x does equal 0. And I know that x plus 7 is going to mean that x equals -7. And then this one is the square root of x plus 8 equals 0, because the 1/2 power is the square root. And so if I square both sides, that means x plus 8 equals 0, and so that means x equals -8. Okay, so now I have to plug all these in and kind of make sure it doesn't make any denominators 0. It looks like I don't have any negative exponents here, so I don't have any denominators. So I'm going to say all three of those answers are good. If you actually plug them in, they would work. All right, next up here, we have some fractional exponents. So I'm going to go ahead and move this over by subtracting it to the other side. And so I get x to the 1/2 plus 3x to the -1/2 minus 40x to the -3/2. Now I'm going to factor out x to the -3/2. And what do we have left? Well, this is going to increase to just squared. 1/2 plus 3/2 is 4/2, so that's squared. We've got 3x to the first, and then minus 40. So we can diamond on that. That's a -5 and a +8. So that's x minus 5, x plus 8, and then x to the -3/2 equals 0. So I can set these equal to 0 individually and solve. This one would say x plus 8 equals 0, which means x equals -8. This one would mean x equals 5. And then this one would mean that 1 over the square root of x to the power of 3 equals 0. Now you can see as I multiply that over, it's just going to say 1 equals 0, which is obviously not true. Or the other way you can think about it, well, usually when you GCF here, x equals 0, but that in this case 0 is extraneous because it is undefined. So I'm not going to include 0 as an answer. We just have 5 and -8. All right, next up here we have 4 terms. Oh, actually, yeah, I want to get them all on one side, so let's move everything to the left. All right, and I'm going to go ahead and do factor by grouping. So the first group, I can take out x to the 1/3, which is the smallest power. Now I'm going to do what I had minus what I took out. And so it's 1/3 minus, no, it's not. It's the other way around. 1/2 minus 1/3. And so we'll multiply this one by 3. We'll multiply that one by 6. Not 6. Multiply by 2 to get it to 6. So get 3/6 minus 2/6. So that would be 1/6. And then this one's gone. And we'll take out a -3 here, which leaves me x to the 1/6 minus 2 as well. All right, so then we'll go ahead and write this as x to the 1/3 minus 3 times x to the 1/6 minus 2 equals 0. So I'm going to say x to the 1/3 equals 3, x to the 1/6 equals 2. And now to get rid of these, a couple different ways you can look at it. You can look at it like we're raising this to the 3/1 power, because that cancels out and makes it x. So that would be 27. Or if you wanted to write it as the 6th root of x, or the 3rd root of x, then you could easily see that you have to raise that to the power of 6. Which is 2, 4, 8, 16, 32, 64. X equals 64. All right, this next one, for an absolute value equation, we always split it up once we isolate the absolute value. So I'm going to say 3x plus 7 equals 5. And then the second time, you change everything that's outside. So I'm going to change this to a negative 5. We're going to solve this both ways. So 3x equals negative 2, and x equals negative 2 over 3. Next up here, we'll subtract the 7. Positive 3x equals negative 12 divided by 3, and you get negative 4. For absolute value equations, you really only need to check for extraneous when you're equal to a number or a negative number or a variable, and so I don't have to worry about it. These are both correct. Our next question here, this one asks right off the bat, it's really asking when does the absolute value equal a negative? And we know that absolute values can only come out positive, and so if you're already, without solving it, if you're asking me when an absolute value can equal a negative, I'm going to say never, and so this is no real solution. All right, next up here, we'll factor this. So we're trying to multiply to 18 and add to 8. So that'll be, wait, what? There's no numbers at work here. So even though this is the 4th power, we actually can use quadratic formula on this. So if you're ever using quadratic formula on the 4th power, you can still do it, but then it's going to be x squared equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to go ahead and try that. So I'm going to say x squared equals negative 8 plus or minus the square root of 64 minus 4 times 2 times 9. And that's all over, let's see, 4. Okay, and I see inside the radical here, I get 64 minus 72. And I can see that that is imaginary because the square root of negative 8. So I'm going to say no real solution. All right, so then this one says factor the expression completely. So I'm going to use u substitution here. We're going to use two variables. So then I'm going to get a u times y squared minus u squared times y. Looks like I can GCF here a u and a y, which leaves me y minus u. Now I'll plug back in. So this is x minus 4. This is x plus 8. And then y here is x plus 8 minus bracket x minus 4. Make sure this was kind of backwards, so make sure you plug that one in for that and then in for that. I put the bracket on the second one because we're going to have to distribute the negative. This is going to become x plus 8 minus x plus 4. It's all going to turn into 12. And so I would say that this is 12 times x minus 4 times x plus 8. All right, next up here, I'll use another u sub for y plus 14. And so we get 49 y to the 4th, u to the 3rd, plus y to the 5th, u to the 4th. It looks like I can GCF here y to the 4th and a u to the 3rd. And that leaves me with 49. That's actually all gone, and then plus y times u. So now I can plug back in. So I get, not u, y plus 14 to the 3rd. And then 49 plus y times y plus 14. And so I need to distribute that in there since the y was being multiplied by the u. I usually use brackets, but I use the parentheses here. So it becomes y squared plus 14y, which I'll just rearrange that as y squared plus 14y plus 49. So then I can factor it as a 7 and 7. So that's going to be y plus 7 squared. And I'll just bring these guys down like so. All right, next up here, I'll use some more u subs. So we get u equals a squared plus 1. I'll just write it as u squared minus 31u plus 130. We'll factor that. And what would that be? Oops, not 13, it's 31. All right. 26 and 5, is it? Yeah. Okay, negative 26, negative 5. So u minus 5, u minus 26, which is actually a squared plus 1 minus 5, and then a squared plus 1 minus 26. So a squared minus 4, a squared minus 25, a plus 2, a minus 2, a plus 5, a minus 5. We're not solving here because it's not equal to 0. All right, next up here, we'll use our u sub. We'll let u equal x squared plus 5. And then we'll use another one, y equals x minus 2. I'm going to multiply these two together, so I get it as 10x, and then u to the 4th, y to the 4th as well. Plus, I'm going to move this 4 out front, and then we get u to the 5th, y to the 3rd. So I'm going to factor out here a 2. I can take out u to the 4th. I can take out y to the 3rd. And then I get 5x, and then y plus 2u. Okay, so now I'm going to plug back in. All right. Be careful here. Make sure you plug back in the correct one. So that's y, so it's x minus 2. And then this one is u, so it's x squared plus 5. All right, so now I got to work in here. So this is going to be 5x squared minus 10x. And then this one's 2x squared plus 10. And so I'll just combine those like terms. So it's 7x squared minus 10x plus 10. You can try to factor that, thinking with two numbers multiply to 70 and add to negative 10. There's no numbers that work there. And so that's all right. I'm just going to write my answer. I'll bring these guys down. So it's going to be 2 times x squared plus 5 to the 4th, x minus 2 to the 3rd, and then I got that box right there. All right, so this one I'm going to let u equal x plus 6, and we get 8x times u to the 4th minus, I'm going to go ahead and rearrange this as 16x squared, u to the 3rd. And then I'm going to factor out here 8x and u to the 3rd, which leaves me with u minus 2x, okay, over u to the 8th. Now that this is factored out, I can reduce it down, and now I can plug back in. So I get 8x times x plus 6 minus 2x all over x plus 6 to the 5th. And then we will simplify here. So 8x times negative x plus 6, which does not cancel out with the bottom because it's different. And then I would distribute up top. You can try that, or you could probably write it as negative 8x squared plus 48x over x plus 6 to the 5th.